one of n+1 numbers chosen from the set 1, 2, 3 up to 2n is divisible by another. So which means you are given a set of numbers from starting from 1 to some even number, and then if you choose more than half of it, n+1, then there will be a number that's one of them is divisible by another. So if you do some kind of analysis for this problem, let's say we have a set of numbers, say up to 6. So this is if I choose 4 numbers, so 6 means n is equal to 3, then n+1 is 4. I need to choose 4 numbers. No matter how I choose 4 numbers, there will be a number, there will be a pair of numbers, one of them is divisible by the other one. So to avoid, so even if I try to avoid this condition, it's very difficult because it already says. So if I try to avoid this one, because if I choose 1 in my 4 numbers, 1 will be divisible, 1 divides all other numbers. So let's say if I choose 4 numbers from these 4, so there are only 5 numbers, so the n is very small, there are only 5 numbers. I have to leave out 1, so I cannot take 2 and 4 at the same time and then 3 and 6 at the same time, because 2 divides 4, 3 divides 6, and then I have to leave out one of each. That brings me, I can choose 4, 5 and 6. If I choose 2, it will divide. If I choose 3, it will divide 3. If I choose 2, it will divide 4. So I cannot choose 4 numbers. If I choose 1, then it will divide any of the numbers. So that's the idea. So the proof is using Dirichlet principle. So that should give, so this n+1 should give some idea. So n+1 is more than half. What we can imagine in these problems is just look at the odd components of the numbers. For example, if I have all the numbers from, let's say, let's take a bigger number, let's say 10. Let me look at this set in the following order. I'll just divide all even numbers by 2 until they become odd numbers. Let's say we have odd number 1 here, 2. I divide it by 2, get 1. So then 3. This one, 4. You can divide it by 2, it becomes 2, and you have to divide it by 2 twice. So that's 1. 5. So this one, divide by 2, it's 3. Divide by, so that's 7. So you can divide it by 2 3 times, becomes 1, 9. And then you get, divide by 2, 5. So here we have only odd numbers. So we divided all even numbers by 2, and here we have only odd numbers. If you choose, so like how many odd numbers we have, that's n, right? Because the half of them. So if you have like 10 numbers, 5 of them are odd, 5 of them are even. So we have 5, 1, 1, 3, 5, 7, 9. So if I choose n+1 numbers from here, from this set, from the second set, it's more than half. So this is 5, this is 6. So which means, so if I try, even if I try to choose all different, so like 1, 3, 5, 7, and then 9, there will be one that repeats again. So let's say 3. So we have 2 3s, right? So these two numbers, the original forms of these two numbers, the repeating odd numbers, let's say, so if you go back to the repeating of these two numbers will be that pair that we were looking in the beginning, um, because so this number, all the numbers we chose, n+1 numbers, they are something like this. Some number a multiplied by 2 to the power x, right? Like it's either 0 or some power. And then this one is again a to the 2 to the power y. And then if you compare, look at these two numbers, if you assume that y is greater than x, it means that a to y is divisible by a to x. So a's get cancelled out, 2 to the power y is divisible by 2 to the power x. So you can, so this kind of proves the statement. So you can just look at the number. So for example, if you have 18, you look at this 18 as if it was 9, right? So, and then if you choose another 9 and 18, they will divide each other. So you take the original set of 2n numbers and then divide all the divisions by 2, and then choose n+1 numbers from there, and there will be some repeating 2 numbers. And then if you go back to the original set, and then those two corresponding 2 numbers will be the pair that you are looking for. One of them, the smaller one, will divide the larger one. So that's the proof of the statement.